Hey guys, welcome back to the recitation on fundamentals of NumPy. In this video, we'll be talking about some of the common math operations that we will be using to solve our homeworks. The main operations that we'll be talking about are broadcasting, elementwise operations, reduction operations, comparison operations, and vector and matrix operations. So let's quickly talk about the broadcasting operation. The simplest example of a broadcasting operation is when we add a vector and a scalar. So let's suppose we have a simple array with values 0, 1, 2, 3, and 4, and if we add 10 to this array, what happens is this 10 is broadcasted to the shape of the simple array and then it's added to each element of the array. So after broadcasting, we have each element of the simple array is incremented by 10. Now let's talk about broadcasting between arrays of different dimensions. Suppose we have a row array with the shape 1, 3 and a column array with the shape 4, 1. And if we add these two arrays, we get an array with the shape 4, 3. And the same operation can also be used for multiplication of two arrays. And again, we get an array with the shape 4, 3. Now let's talk about element-wise operations. Suppose we have two arrays of the same shape, which is 2, 3, and if we add these two arrays, what happens is the elements of these arrays are added element-wise, and we get a third array of the same shape. And so we can see that the element at index 0, 0 of the first array has been added to the element at 0, 0 of the second array, and that's how we get this value. And similarly, the element at 0, 1 has been added to the element at 0, 1 of the second array, and that's how we get this value, and this is repeated for the rest of the elements. The same element-wise operation can also be used for multiplying the elements of two arrays, and this is the result that we get by doing that. Now let's suppose we multiply minus 10 with the random array, and now all the elements in the random array are negative, and we can use the ABS function, which will return the absolute value of the each element in that array, and that's how we get this result. We also have a sqrt function which returns the square root of each element in array. Now let's talk about the reduction operations that we can perform on a NumPy array. Suppose we have a array with the shape 2, 3. We can use the max or the min functions to find the maximum or minimum values in these two arrays. We can also use the sum function to find the sum of all the elements in this NumPy array. And we can use the mean, the std, and the norm function to find the mean or the standard deviation or the norm of any array. And finally, we can also use the argmin or the argmax operations to find the index of the minimum or the maximum elements in that array. But here we also have to specify the axis along which we want to find the index of the minimum or maximum values. Now let's talk about the comparison operations that we can perform on NumPy arrays. So again, we have two arrays of the same shape, and we can use the greater than, less than, or not equal to operations, and these will return arrays of the same shape, but these will have boolean values as their elements, and these these comparisons will be done element-wise on each array. We also have the any and all methods that we can use with the comparison operations. So the any operation returns a true if any of the elements in random array 1 are greater than any of the elements in random array true, and the all operation returns a true if all the elements in random array 1 are greater than all the elements in random array 2. We can also specify the axis with the any and all operations, and these will work in the same way but just along the axis that we have specified. Now let's quickly talk about the vector and matrix operations that we can use with NumPy arrays. So we can use the np.matmul function to multiply two arrays, and we can also use the at operator to do the same thing. This operation can also be used to multiply a matrix and a vector, and also two matrices. We can also use the np.dot function to find the dot product between two arrays. And if the two arrays have only two dimensions, we can also use the at operator to do the same thing. Now let's quickly talk about the tensor dot operation. And this operation is very important because we will be using this in homework 2, where we will be working with convolutional neural networks. So let's suppose we have a NumPy array with the shape 3, 4, 5, and another NumPy array with the shape 4, 3, 2. And so while using the tensor dot operation, we need to specify the axis along which we want to perform the sum reductions. And so for array A, the axis is 1 and 0, so 4 and 3. And for array B, the axis is 0 and 1, so again 4 and 3. And what happens when we perform the tensor dot operation is the axis along which we perform the sum reductions collapse, and we get a new array with the shape 5, 2, and that's what we get here. The tensor dot operation can also be broken down into a 4-layer for loop, and we can compare the output of the tensor dot operation and the output we get from the for loop, and we can see that they're all the same. So it is highly recommended to use tensor dot instead of for loops whenever you can, because using the tensor dot operation is a lot more efficient and a lot faster. And that's it for this recitation.